Hello everyone, and thank you for watching. In this video, I'm going to go over the homework for the AP free response question number 3. And we're going to start with this one here. Here we have a window wiper blade on a car, rotates back and forth. When the wiper blade is farthest to the left or farthest to the right, the measure of the angle formed by the wiper and this vertical center line, which is right here, is going to measure 0.75 radians. Now at t is equal to 0.5, the wiper blade is farthest to the left. The wiper blade then rotates to the right, passing the vertical line, and at t is equal to 3 seconds, the wiper blade is farthest to the right for the first time. Then the wiper blade rotates to the left, passes the vertical line, and is farthest to the left again at t equals 5.5 seconds. As the wiper blade rotates, the measure of the angle formed by the wiper blade and the vertical central line periodically increases and decreases. Now, a sinusoidal function h models the measure of the angle in radians formed by the wiper blade and the vertical central line as a function of time t in seconds. A negative value of h indicates that the wiper blade is on the left, and a positive value of h indicates that the wiper blade is to the right. So here we are on the left side, so this is going to be negative. And then we are on the right side, so that's going to be positive. So the wiper blade again. So the first part here, and now that we have the scenario, the graph of h is dotted again by the midline, 2 full cycles. Points F, G, J, K, and P are labeled on the graph. No scales indicated, and no axes are present. Determine the possible coordinates for t and h of t for these 5 points. Okay, so first of all, our center line is going to be 0, since the farthest to the right gives us a radian and an angle measurement of 0.5 radians, and to the left it will be negative. So adding those two numbers is equal to 0, and dividing 0 by 0 is equal to 0. So our midline is 0. Now, since we're starting at the left, again, that means that we're going to start at the very bottom. So that means that at t equals to j, so at this position right here, that's equal to 0.5. Okay. Now we're going to, the wiper blade is going to rotate to the right, and at t equals to 3 seconds. Here it is, t is equal to 3 seconds. Sorry, I meant to do that in green. At t is equal to 3 seconds, the wiper blade is going to be farthest to the right, so it's going to reach its highest radian of 0.75. So that occurs again at 3 seconds. And then the next time we're going to reach again the bottom, or be farthest to the left, is at 5.5 seconds. So we're farthest to the left at 0.5 and 5.5 seconds, which means that our period here would be 5.5 minus 0.5, which is equal to 5 seconds. So if I get those 5 seconds and divide it into 4 equal parts, that's going to be 1.25. So it takes 1.25 of a second to go from one point to the next point. So from J to P, that's going to increase again 1.25 seconds. So that's going to be 1.75. And then 1.75 plus another 1.25, that's a total of 3. So if I go in the opposite direction, this right here, I'm going to simply subtract that number. So here, I subtracted. You see, I did all the work already, so I subtracted the 1.25 to get negative 0.75, and then I subtracted again 1.75 to get negative 2. Now remember, this requires again no calculator use, so we should be doing the math again by hand. And then we have our values. So at F, the coordinate for F would be negative 2, 0.75. The coordinate for G is negative 0.75, whether the Y value is equal to 0. And then we have the other one, 0.75. It's at the bottom, so negative 0.5 is the Y value. The X value of K is 1.75, and the y value is 0. And finally, P has a x value of 3 and a y value of 0.75. So there's your answer to part A. Now for part B, we need to figure out the values of A, B, C, and D of this graph using a sinusoidal function sine, okay? So the value of A, recall, is going to be the distance of the amplitude. So that value from 0.75 to 0, that's a value of 0.75. And the midline is located at 0. So the value of A is this value, and the value of D is equal to 0. Okay. Now for part B, the way we're going to figure out part B is by getting to 2 pi and dividing it by r period. Now we determine the period again from the part A, that the period was equal to 5 seconds. So that means that B is going to be 2 pi divided by 5 seconds, which just equals to 2 pi divided by 5. Okay. And now here's where we have multiple correct answers. We can use, again, the following values to figure out the value of C. Since C is going to be the horizontal shift, a sine function can start either here at this position, and then we have one cycle right there, or it could start here at this value of k and go again like this. So for the sine function, I'm simply going to use k because I don't know what the time value or the x value is at this position, and I do know what the x value is at k. So since the x value at k is positive 1.75, then that means that from the origin I would have to move it to the right to 1.75, meaning that the value of C is going to be negative 1.75. So there's your answers for A, B, C for part B. A, B, C, and D for part B. Now for part C, it has 2 questions. Refer to the graph of H in part A. The t-coordinate of G is T1 and the t-coordinate of J is T2. On the interval from T1 to T2, which of the following is going to be true about H? So they're basically asking us, if we look at G to J, which of the following statements is going to be true? So G to J, okay, we are going downwards, so we're decreasing, and we start with the value of G being positive to the value of J being negative, so we're decreasing at the interval. So the correct answer here is that H is going to be a negative value, because again, starting with less than T1, not including again that T1, we're going to see that Y value is negative and it's decreasing. So this answer choice here is the correct one. And now for parts 2, describe how the rate of change of H is changing on the interval from T1 to T2. Well, again, looking back at the graph from T1 to T2, again, since we're going down, the rate of change is going to be a negative number, and since we're concaving upwards, it's increasing. So that's our answer. Now all we have to do is write in a complete sentence. The rate of change of H is negative because it's going down, and increasing because it's concaving upwards. Increasing. So now let's move on to the second question. For question number 2, we have this diagram of a car, and the scenario is that we have a car is making donuts in a parking lot next to a brick wall. At t is equal to 3 seconds, the car is farthest from the wall, which is a total of 25 feet. So if this is my wall to this end over here, that's a total of 25 feet. The next time the car is going to be farthest from the wall is at 9 seconds. The center of the circle to the wall has a distance is 14 feet from the wall. So the distance from here to, well, that's not the center, but to the center, okay, that's a total of 14. So that means that anytime the car is here or up there, okay, that the car is going to be 14 feet from the wall. The sinusoidal function H is going to model the distance of the car from the wall in feet as a function of time in seconds. Okay, so the car is going to travel in a constant rate, and the distance between the car and the wall is going to periodically increase or decrease. So again, like the previous example, part A, we need to identify the x and y coordinates of the 5 points F, G, J, K, and P. So let's do that. Okay, so since we know that when we're furthest from the wall, that's going to be again in this function is going to be the highest up. That's going to be 25 feet. When we're in the middle, the car is 14 feet from the wall, which means at the closest level, when it's here, when the car is located right here, that's going to end up being a total of 3 feet, since the distance from the furthest to the wall to the middle location where it's at this position, that distance is equal to 14, and that is a difference of 11 feet. Then that means that the distance from the middle to when the car is closest to the wall also has to be a distance of 11 feet. So those are our y values. So we have the y values of every single one of these points already. I'm not going to write it there. I'll write it in a second. Now, we are given the fact that at t is equal to 3 seconds, this right here, that the car is going to be farthest from the wall. So that occurs either at point F or at point P. I'm going to start, obviously, at point F and go from left and right. So at t is equal to 3 seconds, the car will be farthest to the from the wall. And then it occurs again at 9 seconds. At 9 seconds, the car is also again going to be farthest from the wall and be a distance of 25 feet. Since that's the length again of one period of a cosine function, then that means that the period will be the difference of those two values, which is equal to 6. And dividing 6 by 4, that means that the distance from one point to another point is 1.5 seconds. So the distance from F to G is 1.5, so 4.5. Let's add another 1.5, so this is going to be 6. Add another 1.5, 7.5, and 7.5 plus 1.5 again brings us to this point of 9. So here we have our solutions to F, G, J, K, and P. We have our X, and now we have our Y, and now we have our X. So here are the solutions for part A. Let's now look at part B. So to find the values of A, B, and C again for a sine function yet again, okay, let's start with the vertical ones. So the value of A, again, we calculated is 11, since from the midline to the top or the midline to the bottom is 11. So our value is 11. And our midline, yet again, is 14. So our answer for D is 14. Now, having the values of A and D gives you 1 point. And to get the other point for the question or part B or question B is to get the value of B and the variable C. To find the value of the variable B, we're going to get 2 pi and divided by our period, which again we determine that our period from question A is equal to 6. So 2 pi divided by 6 reduces it to pi over 3. So pi over 3 is the answer for that. Now for part C, we want to create a cycle of sine. Well, similar to the last example, there's 2 places where I can create the sine cycle, either starting here and create 1 cycle there, or start better at K and create 1 cycle of sine from there. So using K, which has an x value of 7.5, we would have to move this to 7.5 to the right, meaning that the value of K would have to be negative 7.5. So there's your other point by getting these 2 parts correct. Now for question C, the first part of question C is on the interval t1 to 2. So we're looking from F this time to G. F to G. Your Y values are both obviously positive, and you're going to G, so you're decreasing. So we have a positive value for H, and it's going downwards. So this second option is the correct answer. And then, well, what's happening there? Describe the rate of change in this interval. Well, since we are decreasing, our rate of change is going to be a negative number. And since the graph is concaving downwards from F to G, that means it's decreasing. It's negative at a decreasing rate. Now the figure shows a clock mounted to a vertical wall at t equals 0 at a vertical wall, and at t equal to 0 minutes, the minute hand is pointed directly to the left at 9. So imagine this pointing there, okay? Pointing that distance right there. And it's 96 feet from the floor. So that distance from here to the floor is 96 feet. When the minute hand is pointed directly down at the 6, the distance to the floor is 88 feet. So the distance from here to the floor is 88 feet. The clock is not working properly, however, and the minute hand rotates one time in 3 minutes. As the minute hand moves, the distance between the endpoint of the minute hand and the floor periodically increases and decreases, okay? So the sinusoidal function h is going to model the distance in inches between the endpoint of the minute hand and the floor. So let's look at what letter A says. Again, question A, same situation. We need to find, again, the coordinates for these 5 points. And since we're given, again, that the farthest that the graph, or the middle point is going to be 96 feet, and the farthest, when it's closest to the, when the minute hand's pointing downwards, that minute hand's going to be closest to the floor, and that's going to be 88 feet. We can figure out what the maximum here, because the distance between the midline to the min and the midline to the max has to be the same. Since this is a distance of 8, that means that the adding 8 from the midline to go up, that would end up being a total of 104. So we have our y values. All we now need to do is figure out our x values. Now we have to be very careful in this particular example, because we might have the tendency of just starting right here, because we're starting in the middle, assuming that this is going to be 0. But because of the direction that the clock hand is moving, now even though it doesn't say it, it is again correctly presumed that the clock is going to move in a clockwise direction, okay? It's not going to move counterclockwise. So from the midpoint, or the midline, we're moving in a upward direction. So we're not going to start here at J and have G have an x value of 0. We're going to have K be our starting time and have an x value of 0, since the next position that the minute hand is going to be pointing upwards and be farthest from the floor, and that distance again is a total of 104 feet. Okay, I'm sorry, inches. 104 inches, not feet, inches. So we would have to start at K and only K in order for this to work. Now, we are told that the period of this thing is 1 time in 3 minutes. So therefore, that means that our period is going to be 3 minutes, which means that the distance from one point from K to P divided by 4 is 0.75. So we're going to add 0.75 to move to the right, and we would subtract 0.75 to move to the left. So here are the x values now. J has an x value of negative 0.75, G has an x value of negative 1.5, and F has an x value of negative 2.25 if I start right here at 0. I could also start it right here at 0 and gone upwards, and this would be those values as well. So that's another option, okay? Starting at this position of 0 and then going upwards. But I started at K, which is fine, and all my x and x values with my corresponding y values are going to be these positions there. And here I have the numbers again. Had I started at this position at 0, since it does go up, it will take me again to F, and this would be the time values of F, G, J, K, and P, the x or t values, the time values at the corresponding height values, x and y. So here you would have. So this would be also another acceptable answer as well. Now for part B, to find the values of A and D, it would not matter which x values you use, whether the blue ones or the black ones, they're going to be the same. For A and B will be the same, since that has to do again with the vertical scales on our sinusoidal function. So the value of A, again, is the distance from the midline to the max, or to the bottom, which again is 8. We had to get that one from the very beginning. And our midline, again, is a total of 96. That was given to us at the beginning. And that will earn you 1 point for getting those two values correct. Now, to get the second point, we're going to get the value of B by yet again using 2 pi divided by the period, which we know is 3. We got that again from right here, that the period was 3. So the value of B is 2 pi divided by 3. And our value of C is going to be, since we're doing a sine function, a positive sine function, we can start at 2 locations. We could start over here, okay, where the time value is equal to 0, or we can start over here at K, where the value is 3, or where the value is also equal to 0, okay, or 3. So there's 2 possible correct answers. If I use the x values that are down here, and I use the value of k, then that would simply be 0. If I would use this value right here, this would end up being -3. Subtracting another 0.75, that will move from -2.25 to there by -0.75, which would end up giving me the value of -3. So my answers are either the following values, either 0, -3, or +3. Any one of those numbers for this value of C would be correct. And let me explain again why 3. 3 again is if we use this value up here. And that would end up being a negative value. Since we need to move it to the right, that would be negative. And if I use this value right here, which is a -3, to move it to the left, I would have to add that number in order for it to move it to the left. And 0 results again either using this +0 or this blue 0 up here, or this blue 0 right here, where k is going to start a new one right there. Okay, so those are the correct values for A, B, C, and D. Now for the first part of question C, we're going to look at the interval from T1 to T2, which is from J is the x value of T1, and K is the T coordinate of T2. So from J to K, here to here, our Y values are both positive and the graph is going upwards. So the first option is the correct answer. And the second part of this one right here, looking at the same values from J to K, since we're increasing, then that means that we have a positive rate of change, and since the graph is concaving upwards, it's also increasing. So here is our solutions to question 2 of parts 2 of question C. Now for question 4, we have here that Mr. Aviles found a deal for a knockoff Roomba on the internet. However, when it arrived, he learned that the Roomba does not operate properly and travels only in circular path, completing 1 rotation every 15 seconds. Now, point B is on the edge of the Roomba and is located directly above the center of the circular path at t is equal to 0 seconds, as shown in the figure. Now, point B is 5 feet from the center of path and 1 foot from the wall. So we know that this distance from here to here is going to be 1 foot, and the distance from that red dot to the center, that's going to be a total of 5 feet. So this is 1 foot, and I'm assuming that's around the center there. And that's going to be a distance of 5 feet. And this is going to occur again at t is equal to 0 seconds. As the Roomba travels at a constant speed, the distance between point B and the wall periodically increases and decreases. So let's figure out what the values are going to be, okay? The Y values first. Well, we know that when we're closest to the wall, we're only 1 foot away. So this value here at the bottom is going to be 1 foot. We're told that the distance from this position here, let me highlight it, in blue, from this position to the center is 5 feet. So that means that's going to be our amplitude. So when the Roomba is located right here, okay, we have that 1 foot right there, adding the distance from here to here, which is 5, that means that the total distance from the wall to when the Roomba right here is in the center is going to be a total of 6 feet. So there's going to be 6. And again, since the radius of the circle is 5, that means that that's our amplitude. And at the maximum, when the Roomba is farthest from the wall, here, that distance is going to be a total of 11 feet. So here we have our y values. And that's going to earn us 1 point when we plot them again in the x and y coordinates for that. Now we're told that at t is equal to 0 seconds, we're going to be only 1 foot from the wall. So we're going to be at its closest value. So at the bottom of this sinusoidal function. So that means that 0 would occur right here where the location of point J is. Or it could also occur over there. But we're not going to start there and work backwards. We'll start just simply right there in the middle. Now, since our period is 15 seconds, one rotation takes 15 seconds. That's up here. One rotation takes 15 seconds. That means that our period is going to be 15 seconds. Now, dividing that period by 15, that period of 15 by 4, that's going to end up equaling to a total of 3.75. So the distance from one position, 1 point, to another point horizontally is going to take 3.75 seconds. Now another perspective is if I start over here, so if I start right here at 0, then this x value would be 3.75, and then adding another 3.75 would get me to this x value. So f can also have the x value of 3.75, which, and continuing it, will give me these x values as well. Okay, so that's just a different perspective. So we have two possible correct ways of representing the x values for f through p. So like I mentioned, you could use either the answers that I wrote on the left or the answers I wrote on the right. You can interchange these because, of course, if you have f be negative 7.5, then g has to be negative 3.75, because that's how much, again, they're increasing. They're increasing by that value. And the same thing is true about the blue ones. Now recall, to get to 2 points, you have to get all of your y values correct and all of your x values correct. So whether you use these right here in black or the ones in blue, they all have to be the same. They have to, again, all be right in order to get, again, full credit for this. Now, regardless of which values you use for the letters A and B, it wouldn't matter. For the A value, that's, again, the radius of the circle, which we're given, again, at the beginning, the amplitude. That's going to be 5. And the midline of our sinusoidal function is equal to 6. So that's going to, again, be irrelevant on regardless of which x coordinates you use. Now, depending on which x coordinate you use, the value of c will, again, will matter. B, not so much, because B is calculated yet again by simply getting 2 pi and dividing it by the period. The period is not going to change whether you use, again, the blue x coordinates or the black x coordinates. And it doesn't even matter also if it's a sine or cosine function. It's always going to be the same format. And since we know what the period here is 15 seconds, that means that 2 pi will be divided by 15. So that is our answer for for variable b, 2 pi divided by 15. So for the value of c, it's very important first that we look at the type of sinusoidal function we want. We have a cosine function, which is going to start at the maximum height, since our value of a that we wrote here is positive 5. So we would have to start at either f or at p. And depending whether we use the blue x coordinates or these bottom x coordinates will determine, again, what value I use. If I use the top ones and I look at f, I would have to use a negative 7.5 in order to move it to a positive 7.5, and the same thing with 22.5. So one set of possible correct answers is that C could either equal to negative 7.5 or negative 22.5. If I yet again was going to use the top ones. If I'm going to use the bottom numbers, well, at P, moving to positive 7.5 would mean that this number would have to be negative, so the same thing as this number up there. But in order to move it to negative 7.5 to the left, I need to add this number again because of the direction that horizontal shifts are affected. So the other option would be that the value of C could also be 7.5. So either of these three numbers for the letter C will mark this question correct. And that would earn you the second point. As long as you have this and this correct, that would earn you the second point for question B. Now for question C, we're going to look at the t coordinates of G is T1, and the t coordinate of J is T2. And again, we're going to look at what's happening there. Okay, so if I look at the values of G to J, first of all, the y values are both positive. Okay, I'm going from positive 6 to positive 1. So all my y values are positive, and then I'm going down. So the correct answer is going to be that H is positive and decreasing. Let's now describe how the rate of change of H is changing on that interval. Well, since the graph is decreasing, that means that the rate of change is going to be negative, and the graph is concaving upwards. It's negative at an increasing rate. So it's negative and increasing. So there you have your solution to the second part to question C. Moving on to question number 5. Here we have a diagram of a sprinkler placed outside to help water the grass. The sprinkler has a vertical target line as shown in the figure. Then the sprinkler head rotates back and forth as it passes the target line. Okay, notice that it's calling it a target line and not a central vertical line. When the sprinkler is farthest to the left, the measure of the angle is formed by the path of the water, and the target line is 0.4 radians. So this distance right here, or this angle, that's equal to 0.4. And when the sprinkler is farthest to the right, the measure of the angle formed by the path of the water and this green vertical target line is 1.2 radians. So this distance here to the right, that's equal to 1.2 radians. Now at t equals 3 seconds, the path of the water is farthest to the right. As the sprinkler rotates to the left, the path of the water passes the vertical target line. And at t is equal to 9 seconds, the path of the water is farthest to the left for the first time. Then the sprinkler rotates right, and the path of the water passes the vertical target line and is farthest to the right yet again at t is equal to 15 seconds. As the sprinkler rotates, the measure of the angle formed by the path of the water and the vertical target line is periodically increasing and decreasing. Now the sinusoidal function h models the measure of the angle in radians formed by the path of the water and the vertical target line as a function of t times seconds. A negative angle of h of t indicates that the water is to the left. So to the left, we're going to be negative. So that means that this here is negative 0.4. And a positive value of h of t indicates that the water is to the right of the vertical target line. So this is a positive 1.2. A sinusoidal function h models the... Oh, I just read that, okay. So here we go. So all we have to do now is figure out the values of A, B, C, F, G, J, K, and P. Now with the information that's given to us, we have that at the farthest to the left, so we can have a negative angle, so that's going to occur obviously at the minimum value on this graph, and the maximum, the largest angle, a positive 1.2, is going to occur at the highest value. Now to figure out what the midline is, or what the middle is, all we need to do is add these two numbers up, 1.2 plus negative 0.4, and divide that value by 2, which is going to give us a value of 0.8. divided by 2, which is equal to 0.4. Now, for the x values, well, first thing we need to do is figure out what the period is. Well, we are given some times here that at t is equal to 3 seconds, the water is farthest to the right. So that occurs again when we have a maximum, so either at F or at P. Well, I'm obviously going to use PF because again it comes first. So we see that value there first, so we'll start at that value, and it's going to reach the right for the first time. I'm sorry, it starts at the right, and then it's for the first time it goes to the left and have a negative angle. That's going to be at 9 seconds, so that occurs here at the bottom at 9. And then the next time it's going to be farthest to the right is at 15 seconds. So our period here from our max to our max would be 15 minus 3, which is 12 seconds. So our period is 12 seconds, which means that if I get to 12 and divide it by 4, that's going to equal to 3 seconds. So the distance from one point to the next point is going to increase by 3, which makes perfect sense, because if this is equal to 3 and this one's 9, then this would have to equal to 6. 3 plus 6 is 9. 3 plus 3 is 6. 6 plus 3 is 9. 9 plus 3 is equal to 12. And 12 plus 3 is equal to 15. Now, so here are the coordinates for F, G, J, K, and P respectively. Now, of course, your y values cannot change, but you could possibly have different x values depending on where you start. Had I decided to start at 3 here, then this would be at 0, this would be -3, -6, and -9. So that could also be an option there, okay? But we'll keep it like this. Now, for the values of A, B, and C, and D, A, B, C, D here, we'll start with the values of A. A is going to be, again, that amplitude, the distance from the midline to the top, which is 0.8, and our midline is 0.4. So our answers is 0.8 and 0.4. Now, to identify the value of B, we're going to get, yet again, 2 pi and divided by our period. In this example, our period is 12 seconds, which reduces to pi over 6. And for part C, well, since we want a sine function, we have 2 starting points for a sine function at this value here or at K. So let's just do it at K. Since the value of K is has an x value of 12, that means that C would have to be -12. And there's your answers for part B and C, or for variable B and C. The values of C could also be 0. Using the bottom numbers I have right here, since these are increasing by 3, that direction, that means subtracting by 3 would give me 0. So if I use this point, the x value right there would be 0. So 0 is also an acceptable answer if we want to continue using the numbers on the bottom. Now for question C, again, the same 2 parts. Here we're going to look at what's true about on the interval of t1 to t2 from K to P this time. So K to P, our y values are positive and it's going up. So the correct answer here, positive and increasing, is that first option. Now describe how the rate of change is changing on that interval. Well, since it's increasing, that means that the rate of change is going to be positive. And going back to the graph is concaving downwards from K to P. So that means the rate of change is decreasing as well. And yet again, here again is the answer. The rate of change of H is positive and decreasing. Okay, moving on to the next question. The figure shows Stephen and his friend together on a seesaw. Point B as the top of Stephen's head. As Stephen sits on the seesaw, the height B above the ground level periodically increases and decreases. At t is equal to 4 seconds, B at its lowest position 24 inches above the level ground. At t equals 1.5 seconds, B is at its highest position 60 seconds above the level ground. The sinusoidal function h models the height of B above the ground level, above the level ground in inches as a function of time in seconds. So for part A, yet again, we're going to identify the x and y coordinates, or t and ht values, for the 5 points. Given the fact that at its lowest position, again, we have that this is going to be 24 seconds. So this right here would be 24 seconds. And we're told that at the highest point, point B is 60 inches from ground level. So that's going to be 60. So to figure out what the midline is, we're going to simply add these two values together, and then that, which ends up equaling to 84, and dividing it by 2, which is 42. So 24 plus 60 divided by 2 tells me that my midline is at 42. So there, I have all the y values. Now to identify the x values, well, we're told that at t equals 4 seconds, point B is going to be at its lowest position. So it's going to be at 24 feet, or I'm sorry, inches from the ground level. So let's have it be right here at point J. So that's going to be at 4. And then at t equals 5.5 seconds, it's going to be at its highest position. So that's going to be right here at 5.5. Well, point K is exactly, the x coordinate of point K is exactly in the middle between those two. So the way we're going to figure out the middle between 5.5 and 4 is the same thing where I figured out the midline between 60 and 24. I'm going to add these two quantities and divide that answer by 2. So that's going to be 4.75. So as you can see, the x values are increasing from one point to another point in increments of 0.75. So again, what I did again, just to recap, I got this value. I know that this is the time, again, that point B is going to be at the highest. And I just simply figured out where the middle is between those, because again, increments, okay? Since this is going to be half of the period, I could also figure out what the length is between those two and simply doubled it. And that would have told me again the length of the period. So half of a period is equal to the distance of 5.5 minus 4 from 4, which is 1.5. And 1.5 times 2 means that the period would end up being 3. And when I get that 3 and divide it into 4 equal parts, 0.75, it's the increments that I'm increasing by. So different perspective to get that value. And this probably, the second perspective is probably best, because we need to identify what the period is anyways. So might as well have gotten that distance from the very beginning. And now we have all of our x values. So here are your x and y coordinates for point F, G, J, K, and P respectively. Now remember, you could also get some other y coordinates, x coordinates for those values. If I was to start, instead of starting at the bottom here at J, I could also start over here to the left of F, start right here at 4, and increase it again by 0.75. And that would give me another set of x values for those 5 points. So now let's look at question B. So we have to find yet again the values of A, B, C, and D. So start with the vertical transformation, start with the amplitude, the vertical dilation. Since the distance from 42 to 60, that is a distance of 18 units, our value of A is equal to 18. And since the midline there is 42, our value for D is 42. Now for the period, for the horizontal dilation, we're going to use 2 pi and divide it by the period, where our period again is up here is 3. So our answer is 2 pi divided by 3. And for our phase shift, so our horizontal shift, C, well, since we want to create a sine function, we can create a sine function by starting here and going up and going down, or again using just k. So if I start at k, go upwards, k starts at the x value of 4.75 or t value 4.75, that means that we would have to subtract it in order to move it to the right. So minus 4.75. So there's your values for B and C respectively. And for part C, the question one in part C, let's figure out if F is T1 and G is T2, what's happening there, okay? So F to G. So F to G, our Y values are both positive and it's going down. And since it's going down, so that's going to be this answer right here, positive and decreasing. Let's describe how the rate of change is changing in those same intervals. Well, since it's decreasing, that means that the rate of change is going to be a negative value, and since it's concaving downwards, it's also decreasing. So again, your answer for parts 2 for question C, describe how the rate of change of H is changing. H is negative, and the rate of change of H is negative and decreasing. Make sure again that you state that you're talking about the rate of change. Don't write H is negative and decreasing, okay? Because that won't give you the full point, because we're talking about, again, the rate of change. So be specific. For problem number 7, here we have a situation where a car travels around a circular track as shown in the figure above. The center of the circular track is 20 inches from the wall. So this distance from here to there is 20 inches. And at t is equal to 2 seconds, the distance between the toy car and the wall is 0 inches. So it's starting right there as indicated, okay? Now the car completes one full lap and around the track every 8 seconds, and as the car travels around the track at a constant speed, the distance between the car and the wall periodically increases and decreases. Now the sinusoidal function h models the distance in inches between the toy car and the wall as a function of time in seconds. So our x values, or horizontal axis, is going to be time, and our vertical axis is going to be distance in inches. Now the graph of h and its dashed midline for 2 full cycles is shown. F, G, J, K, and again P are labeled. No scale is indicated, no axes are present. Determine again the coordinates t and h of t for these 5 points. So let's first start off by figuring out what the following is going to be the vertical axis. So the vertical axis, well, when the toy car starts right here, as is stated here, it's 0 inches from the wall. So the minimum would be 0, and the midpoint would be 20, because when the car is right here, that distance is going to match again to the radius of the circle. So 20, which means that the maximum when the car is farthest from the wall is going to be 40. So there are the y values to F, G, J, K, and P respectively. Now we are told that at t equals 2 seconds, the distance between the toy car and the wall is 0 inches. So it's starting at the minimum value. So the starting point right there. So that means we have to start at 0 inches. Okay, so 0 inches, there's 2 places, J, or this position over here in the very front. But let's just position again at J. So let's start and have this position be right here at 2. Now we know that the period is 1 full lap in every 8 seconds. So our period is going to be 8, which means that 8 divided by 4 is equal to 2. So the distance between every single point is 2 seconds apart. So 0, and this would be -2. If I start right here. So here are the coordinates for F, G, J, K, and P. Now the y values again do not change, but just to remind you that the x coordinates of these points could have other possible correct answers. It all depends again where you start that initial value, which in this case is at t is equal to 2, where you decide to put that. You could put that 2 right here, and that would mean that this would be 0, and then -2, -4, -6, -8, and -10. That's one possible answer. What I did up here in blue is that I started in front at the very beginning right here and made this one equal to 0, which means that this would be 2. I'm sorry, I started here at 2, not 0, at 2, which means that this one would be 4, and then F would be at 6, 8, 10, 12, and 14. And so the same thing here, not at 0, but at 2. So 2, this would be 0, like I mentioned, and then -2, -4, -6, -8, and -10 as well. So that's another possible option for the x coordinates of these 5 points there. Okay. Now for question B, again, find the values of A, B, C, and D. For the vertical transformations, the vertical dilation of A, that's going to be our amplitude. So that is a distance of 20. And since our midline is 20, the answer to A is 20, and that happens to also be the answer to B. Now for the horizontal transformations, the horizontal dilation, we're going to figure that out by getting to 2 pi and dividing it by our period, which our period was 8. So that reduces to pi over 4. And to find again the horizontal shift, because it's a cosine function, let's pay attention to that. It's a cosine function. Our cosine function has to start at the maximum value since we're having a positive value for A. So there's 2 possible correct answers here. We can start at F or we can start at P. If I start at F using the bottoms of the number, the value of A would have to be a positive 2. I'm sorry, the value of C would have to be a positive 2. Or if I was going to do point P as the starting point using the bottom number, that would have to be a -6. If I use the top numbers, a positive 6 would be -6, which is already there. And if I was to use 14, this number up there, using the top numbers, then I would have to subtract 14. So any one of those 3 numbers, again, will satisfy for the value of C. Now for part C, same situation as before. The t coordinate, we're now going to look at the t coordinate of G, a T1, and the t coordinate for J, which is at T2. And we want to know what's happening again to the values of H, which again are the y values in that interval from T1 to T2. So T1 to T2, so from 0 to 2 seconds, the y values are going downwards. We're going from 20 to 0. So that means that our answer for this problem is that H is going to be positive and decreasing. Now in the same interval, what do we know about the rate of change of H in that same interval? Well, since it's decreasing, that means that the rate of change is going to be negative. And since the graph from G to J concaves upwards, that means that the rate of change is increasing. So there's your answer for question 2, or parts 2 of question C. Now for question number 8, we have a Ferris wheel here rotating in a circular clockwise direction. It completes 1 rotation every 30 seconds. So there's our period. Point B at the top of one of the enclosed passenger carriers, and point X does not move. So let's find those values. So we have again this point right there, and we have this point X that is not going to move. As the Ferris wheel rotates at a constant speed, the height of B moves X periodically above X. The height of B above X periodically increases and decreases. At t is equal to 0 seconds, B is at its lowest position. So this point B is going to be down here, and that's going to be 10 feet directly below the x-axis, as you see right there. Okay, so -10. At its highest position, B is 40 feet directly above X. So up here, that distance from X is going to be 40. Now the sinusoidal function H models the height of B above X in feet as a function of time in seconds. A positive value of H indicates that B is above, and a negative value of H indicates that B is below. So let's look again for the values of the x and y coordinates to these 5 points on this sinusoidal function. So as indicated, if point B is at the highest, then we're going to be at positive 40. And if point B is at its lowest, that's going to be negative 10. And well, to determine again the mid line, we simply add these two quantities and divide it by 2, which is going to equal to a total of 15. So the midline is 15. So we have our y coordinates for these 5 points. Similar to the other problems that we've done today, on this homework assignment at t equals 0 seconds, B is at its lowest position. So we're going to start at the lowest position of 10. So again, that's several options over here, here, or my favorite spot right there at J. So we're going to start here that this is going to be 0. Now, since the period equals to 30, we're going to need to divide 30 by 4, which is going to be 7.5. So the increments from J to K to P is an increment 7.5. So this adds 7.5. This would be 15. And the values over here to the left of J would subtract 7.5. So negative 7.5 and negative 15. So we have now our x coordinates. So here you have your answers for the coordinates for F, G, J, K, and P. So we can move on to now question B, and again finding the values of our of the constants A, B, C, and D. So for A and D, the vertical transformations, our amplitude is 25. 40 minus 15, that's a difference of 25, and our midline is at 15. So our A again is 25, our midline is 15. So those are the values for A and D respectively. I indicated the period at the beginning of the problem, and it was 30. So that would mean that the value of B would be 2 pi divided by 30, which can be simplified to pi over 15. And the value of C here, since we want a sine function, let's start that sine function at the same place as all the other sine functions at K. So the x value of K is 7.5. So moving it to 7.5 to positive 7.5 means that we would have to subtract it. So negative 7.5. Now for the next part, question C, we're looking now at J, which is T1. The T coordinate for K is T2. And we want to see what's going to be true about the y values, about H, the y values from T1 to T2. So let's look at J to K. So from J down here to K, we're going from negative 10 to positive 15. So we are negative. We will get to a positive value, but from here we're negative and going upwards. So the y values start off as negative. They will go upwards to positive eventually, but they'll continue increasing. So we'll select this answer as the correct answer. Now, what has to be true about the rate of change of H in that same interval? Well, from J to K, because it's increasing, we know that the rate of change is positive, and because it's between J and K, again concaving upwards, we know that the rate of change is also increasing. And because it's the final answer, the final question, I thought it'd be a little bit more elaborate on this answer here, stating that the rate of change of H on the interval T1 to T2 is positive and increasing. So just a little extra zazz again to this, and notice again how I'm using the question to create a sentence to answer. So again, answer in full sentences. So that concludes again the homework for question again this last one, and that concludes the homework for the free response question number 3. If you have any questions or you see any errors throughout this video, please let me know. And like I always appreciate you watching, and I hope you have a great day. Goodbye.